All right, 9.3. First a warm-up, which reminds us of the last unit. Sorry, I'm sort of skewed in how I set this slideshow up, so everything's small and skinny, but it's okay. We'll still get there. So yeah, let's go ahead and do this warm up and make sure we remember what's going on. So in a right triangle, ABC, C is the length of the hypotenuse, A is 3, that doesn't make sense, A is 3, and B is 5. If you evaluate sine A, cosine A, and tangent A, first of all, we need to do the Pythagorean Theorem to find the length of C. So we're going to do 5 squared plus 3 squared equals C squared. 25 plus 9 is 25, 34. Square root of 34 is C. Sine A, so is sine equals opposite over hypotenuse. So I've got opposite. Oh, sorry, let's do this. So this is C, A is 3, so this is angle A, B is 5, so this is angle B. So I've got sine A is opposite over hypotenuse, 3 over root 34. Let's rationalize it. Multiply by root 34 over root 34. I get 3 root 34 over 34. I'm going to check really quick. 34 breaks into 2 times 1, 17, and now we're prime. So we're good. There's my answer. Cosine A. Cosine is adjacent over hypotenuse, so 5 over root 34, which is, that should be an equal sign, sorry. 5 root 34 over 34. And then tangent A is opposite over adjacent, so opposite over adjacent, 3 over 5. Evaluate cosine of 60. 60 is, that's going to be our 30, 60, 90 triangle. So here we have 60, 30, and right. So that's our 30, 60, 90 triangle. Cosine is adjacent over hypotenuse. So cosine of 60 degrees is adjacent over hypotenuse, 1 over 2. Secant 45, that's my 90, 45, 45 triangle. That's going to be 1, 1, root 2. So secant 45 is cosine negative 1. Remember, secant is 1 over cosine, or cosine negative 1. I know that cosine of 45 is adjacent over hypotenuse. Therefore, if I take the inverse of that, it's going to be just root 2, or root 2 over 1. And then cotangent 30, there's 30, 60, 90. Across from the 30 is 1. Across the 60 is root 3, and that's 2. Is that the one I did over there? Hold on. Yep, I had to check something. It is. So tangent of 30 is adjacent, opposite over adjacent. So 1 over root 3 is tangent of 30. Cotangent is 1 over tangent, or 1 over root 3, or just plain old root 3. All right, so let's get into our lesson. First thing we need to do is talk about a key concept. General definitions of trig functions. So this is not 90-degree triangles. Okay, this is any angle. So general definitions of trigonometric functions. Let theta be an angle in standard position, and let xy be the point where the terminal side of theta intersects the circle. Okay, we're now talking about the unit circle again. The 6 trig functions of theta are defined as follows. So if we've got theta anywhere, I've got sine of theta is the y value over radius. Because sine is opposite over hypotenuse, so I'm just going to draw that a little bit bigger. Here I have my radius, because this is the unit circle, right? So let's see if I can draw a circle here. That means that would also be my radius. That's my x value. Let's see if I can do it. Okay, it's going to go down past here. There's my coordinate plane. So this value right here is the radius of the circle. It's also the hypotenuse of my right triangle. This right here is the x value. And let's see if I can get a different color. This right here is the y value. Notice the x value on this triangle is negative, the y value is positive, and the radius is positive. So here when I have sine theta, let's draw theta in there. There's theta, that measurement right there. So sine theta, theta is here, so I have opposite over hypotenuse, y over radius. Cosine theta is x over radius. Tangent theta is opposite over adjacent, y over x. Okay, x can't be 0. Circular functions here, what I've always remembered is sine is y, cosine is x, tangent is y over x. That also means that tangent I can calculate by doing sine over cosine. Okay, it's a good thing to remember. So sine equals y, cosine equals x, tangent equals y over x. And then the inverse. So your unit circle. It's convenient to use the unit circle to find trig functions of a quadrantal angle. Quadrantal angle. You know, I practiced that before I started recording, and I still totally flubbed it up. An angle in standard position whose terminal side lies on the x-axis. So the x-axis here, so my angle's like this, my angle's like that, like this, or like that. But it has to lie on the x-axis because that gives us all of these values. This would be negative x, and then over here I've got negative y, right? And positive, or negative y. An angle in standard position. The measure of a quadrantal angle is always a multiple of 90 degrees, or pi over 2 radians. So let's try an example. Let 4, 3 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions of theta. So as usual, I'm going to draw this more. So x is negative 4, positive 3. Here is theta. I've got a right angle. So this is x, I'm at negative 4, y is positive 3, and we can find out r. 3 squared plus negative 4 squared equals r squared. 9 plus 16 is 25. So r equals 5. So sine theta is opposite over hypotenuse, 3 over 5. Cosine theta is adjacent over hypotenuse, so I've got negative 4 over 5. Tangent theta is opposite over adjacent, 3 over negative 4. And then all of the opposite ones, the reciprocals, cosecant, secant, and cotangent. Just flip them. Cool. Okay, just a point of reference here, this negative sign, it doesn't matter where it goes in the fraction, it just has to be there somewhere. Okay, it doesn't have to be in the numerator or the denominator or anything, it just has to be there somewhere, right? All right, use the unit circle to evaluate the 6 trig functions of theta equals 270. Here we're going to do it a little bit different. If I look, 270 gets me right there. So this point right there is my terminal side, I'm in standard position, etc. So let me erase that. So at this point right here, I don't know why I erased that, because there we go. That point right there, I have 0, negative 1. So x equals 0, y equals negative 1. And the radius of the circle is what we would look at. Oh, I can't erase it, sorry. The radius of the circle is that measurement right there or that measurement right there, which the radius is then just the value 1. I can't have a radius of a positive or of a negative, so it's always positive. So let's just do our sine, cosine, and tangent using the y's, the x's, and the r's. So sine, cosine, tangent, sine equals y over r, negative 1 over 1. Cosine is x over r, which is 0 over 1, which is 0. And tangent is y over x. So I've got negative 1 over 0. And you cannot divide by 0, so it's undefined. Now, the opposites of those, I'm doing them right underneath here. Cosecant, secant, and cotangent. It's the reciprocal, remember? So I've got 1 over negative 1, which again is just negative 1. I have 1 over 0, which is undefined. And then I have 0 over negative 1, which is 0. Cool? So I found out where my point was, and I used that just in my x's and y's. Right, evaluate the 6 trig functions of theta. We need to know what x, y, and r are. So let me go ahead and draw this triangle out. This is where we are. That's theta. It's a right triangle. I have x and y. X is 3, y is negative 3. Let's find out what r is. So 3 squared plus negative 3 squared equals r squared. 9 plus 9 is 18. Square root of both sides. R equals the square root of 18. Let's simplify that. 9 times 2, 9 is a perfect square, so I can take a 3 out. So radius equals 3 root 2. Okay, so let's do our trig functions. I know sine is y over r, so I've got negative 3 over 3 root 2, which is negative 1 over root 2. First, let's find cosecant theta, because I can just take the reciprocal of sine theta, and I have root 2 over negative 1, which is just negative root 2. So I'm done with that one. Now let's go back to sine theta. I need to rationalize that, which we've learned, by multiplying by root 2 over root 2. So I get negative root 2 over just plain old 2. Cool? Cosine is x over y. 3 over 3 root 2 equals 1 over root 2. So secant's the reciprocal of that. Root 2. Now let's rationalize this. So I get root 2 over 2 for cosine. Tangent is y over x. So negative 3 over 3, which is negative 1. Y over x, yep, and cotangent is the reciprocal of that, which is negative 1. Cool. Okay, why don't you try this and see what happens? I'm going to draw this triangle and solve for it. So I'm going to push pause and work. I ask you to work on your own and see if you can get the same answer as I do. This one was a bit easier because we didn't have to rationalize any denominators, which was pretty sweet. Okay, next. First I'm going to make this triangle right here. Yeah, but try this one on your own. Cool, be right back. Push pause. So here are the answers. Okay, check them out, see if they're the same as your answers, and let me know if you're not. I'll help you out. All right, last guided practice. Use the unit circle to evaluate the 6 trigonometric functions of theta equals 180. Well, if I've got the unit circle, theta equals 180 is that. So if I look, my radius equals 1, x equals -1, and y equals 0. So go ahead and plug those in and check your answers. Push pause, please. There you go. All right, our next key concept, reference angle relationships. Let theta be an angle in standard position. The reference angle for theta is the acute angle formed by the terminal side of theta and the x-axis. The relationship between theta and theta prime is shown below for non-quadrantal angles theta, such that 90 is less than theta is less than 360. Okay, actually a few of the problems that I've solved in this lesson so far, I've been using this concept, so I apologize if I've confused you. Theta is always our given angle, but the angle that we deal with is the one that's formed by the terminal side, okay, back to the x-axis. So we have theta, but the angle we're going to mess with is the one that is formed back to the x-axis. Even here, okay, we're going to go back to the x-axis. And that just means our theta prime is going to be less than 90 degrees. Okay, so theta is more than 180. Theta prime is less than 90. Okay, theta is more than 180. Theta prime is less than 90. Okay, this one right here is just more than 90. So that is going to be less than 90. So we're just going to look for the reference angle that is less than 90 degrees. So let's try one. Find the reference angle theta prime for A. Theta is 5 pi over 3. And B for theta is -130. So let's work with A first. 5 pi over 3. If we look at our unit circle, this is pi over 2, that's pi, and this is 3 pi over 2. If I just look at the, just the fraction, 5 pi over 3, that gives me 1.666 repeating pi. I know that 0.6667 is 2/3. So I've got 1 2/3. That means I'm going to go 1 and 1/3, 2/3. It's over here in quadrant 4 somewhere. So let's go ahead and say 2 pi minus 5 pi over 3 is going to get us to quadrant 4. So 2 pi minus 5 pi over 3 is pi over 3. So that right there is my reference angle. Okay, that would be this angle right there. Let's look at B. -130. So we're going this direction. This would be 90. This is 180. So -130 is somewhere in quadrant 3. So if I take 180 minus 130, that gives me 50 degrees. So I'd be over here in 50 degrees. Right, key concept. Evaluating trig functions. Use these steps to evaluate a trig function for any angle theta. Step 1, find the reference angle theta prime. Step 2, evaluate the trig function for theta prime. Step 3, determine the sign of the trig function value from the quadrant in which theta lies. Yep, we really don't want to memorize these per se. What I always remembered is just the xy. So here I have xy is positive, positive. Xy is negative, positive. Xy is negative, negative. And xy is positive, negative. And we know things like cosine, sine, and tangent. Cosine is y over r. R is always positive. So here cosine is positive. Well, I can't say that in that drawing, sorry. Sine is, oh gosh, I wrote them backwards. Sine, cosine, tangent. Now I can do them in the right order. So I basically just know these signs and use them in the y over r, x over y. Maybe I shouldn't be doing this, I'm tired. That's an r. Y over r, x over r, and y over x. And then, cosecant, secant, and cotangent are the opposites. R over y, r over x, and x over y. So if you remember that, you don't have to memorize this stuff. You just have to know the signs. I mean, this is the x-axis, it's positive, positive y-axis, negative x-axis, negative y-axis, right? All right, so let's evaluate. First, I'm going to look at negative 240. So negative goes in this direction. So I've got 180, but I need to keep going. So 180 plus 90 is 270. So that's right there is 270. So we're in quadrant 2 somewhere. So over here somewhere. So if I have 240 and I take away 180, that gives me 60 degrees. Okay, so the reference angle we're looking for is right here, 60 degrees. So I know that tangent of negative 240 is equal to 60. And if I go back and look at the chart that I learned in 9.2, I know that tangent of 60 is root 3. But since I'm in quadrant 2, tangent is y over x. And in this case, my x is negative. So my answer is negative, which is why I put that right there and right there. So again, I've never memorized that chart, the reference chart that we just talked about. I just go to what quadrant I'm in and that my x value is negative. My y value is positive. All right, let's try cosecant 17 pi over 6. 17 divided by 6 is 2.83. Okay, that's just trying to get me what quadrant I'm in. So what I'm really doing here is I'm going around once, that is 2 pi, and then 5/6. So the angle that I'm looking at is right here. So if this part right here is 5/6, I know that this part right here is 1/6, because 5/6 plus 1/6 is 1, and that is pi. So it works. So the angle I'm looking for right here, theta, is 1/6. So 1/6, I'm going to say that's pi over 6. If I change pi over 6 into degrees, the pi's cancel. 180 divided by 6 is 30 degrees. So cosecant is 1 over sine is 1 over sine is y over r is r over y. And in this direction, my y is positive and my r is positive. So if I look at that chart from last section, I can say that cosecant of 30 degrees is going to be positive 2. It's my 30, 60, 90 degree triangle. Nope, I already did this one. Sorry. All right, let's try sketch the angle and find the reference angle. So if I look at 210, I've got 180. This is 270, so I've gone too far. So 180, 210 is going to be in quadrant 3. 210 minus 180 is 30. So my reference angle would be right here, 30 degrees. Okay, negative 260. So I start this direction. I've got 180, but it's not far enough. 270 is too far. So it's 10 degrees shy of 270. Right there. It's 80 degrees. To see the math, I would do 260 minus 180, 80 degrees. Okay, sketch the angle, then find its reference angle. It's negative, so I've got 7/9 is less than 1, so I'm in quadrant 1, 2, 3 somewhere. 9/9 pi is 1 pi, which is 180 degrees right here. So if I'm at 7/9, how many ninths do I need to make a whole? How many pieces of pie do I need to make a whole pie? 2. So I believe I'm right here, where here's my reference angle, and theta equals 2 pi over 9. 15 pi over 4. 15 over 4 is 3 3/4. So that's how many pies. I've got 1 pi, 2 pi, 3 pi, and 3/4 would be 1/2, 1/4. 3/4 is over here. So my reference angle is what's left. So if this is 1/2 and 1/4, so this whole piece right here is 3/4. What's left is 1/4. That was sort of fun. And evaluate cosine negative 210 without using a calculator. Without using a calculator, that means that we have a special triangle. So if I'm at 180, 270 is too far. So 180 plus 20 is 200, plus 10 is 30. So we're right here. That's my reference angle. Y is positive, X is negative, and R. Theta is 30 degrees, which is a special triangle. So if I check the chart, I know cosine theta is X over R. So it's negative. Check the chart. I've got square root 3 over 2. The Frogbot is a robot designed for exploring rough terrain on other planets. It can jump at a 45-degree angle and with an initial speed of 16 feet per second. On Earth, the horizontal distance d in feet traveled by a projectile launched at an angle theta and with an initial speed v in feet per second is given by d equals v squared sine 2 pi. How far can the Frogbot jump on Earth? So what is my distance on Earth? Let's see, I have an initial speed of 16 feet per second. I know that my degree of angle of leaping frogs is 45 degrees. So I can use all of that. D equals 16 squared over 32. Sine of 2 times 45 degrees. I'm going to pull out my handy dandy calculator. 16 squared divide by 32. Then I have sine of 2 times 45. Okay, as you type everything in your calculator, make sure your mode is in degrees. And if you type all that in, you get D equals 8 feet. Okay, last example. Rock climbing. A rock climber is using a rock climbing treadmill that is 10.5 feet long. The climber begins by lying horizontally on the treadmill, which is then rotated about its midpoint by 110 degrees. Okay, that's that right there. 110 degrees. So that the rock climber is climbing towards the top. If the midpoint of the treadmill is 6 feet above the ground, how high above the ground is the top of the treadmill? So we're looking for this distance. How high from the ground is the top of the treadmill? So really, if we can find this distance, then we'll add it to 6 feet. So what I really want to find is, so if this is 110, I really want to find this distance. So what is theta? I've got 180 minus 110 is 70 degrees. That is theta. We know that that R is 5.25 feet, but we don't know this measurement. But if I have theta, theta is y over r. So some trig function of theta is y over r. If I look, y over r is sine theta. So sine of 70 is y over 5.25. So if I solve for that, I can multiply this over here and say y equals, typing it in, 5.25 times sine 70. So about 4.9 feet plus 6 feet equals 10.9 feet. Sort of fun. Right. Last practice. Estimate the horizontal distance traveled by a track and field long jumper who jumps at an angle of 20 degrees with an initial speed of 27 feet per second. So we're going back to that distance equals velocity squared over 32, I think. Checking. Yep. Sine of 2 theta. So 27 squared over 32 times sine of 2 times 20. Let me start typing. 27 squared. 27 squared divide by 32 times sine of 2 times 20, or 40. I got 14.6 feet. Check the answer key, because I love doing that. Yep. Good job. That's it for today. Okay, that was long, so good work.